Okay, hello. Welcome back to Math Made Possible. I believe I can. I'm your current teacher, Miss Howard, and today we're going to be doing a part two to our fifth grade illustrative math curriculum. We're going to be doing a summary for Unit 2, Lesson 11. Again, this is a part two to the previous video that I had shared before because we did some more strategies today, and I just want to make sure that I put this in a video so that everyone can truly understand how to find the area of rectangles. Now, we should also know that the area of the rectangular formula is area equals length times width. Okay, so all of these expressions are going to be some form of representation of that, and I'm going to break it down for you so that you have a better understanding. All right, so as we can see here, it's the first expression that we have is 14 over 3 times 4. So how do we see 14 over 3? Well, first of all, we have to take a look at this area right here. This box right here represents one whole unit, and you will know that by the brackets that you see here. And you see a number 1 above it. Okay? Before, when you were looking at images, you were seeing that the whole side was represented by 1, which meant that you had to see what fraction was shaded. So in this case, you see one whole unit. So let's go ahead and count that. That's 1, 2, 3, 4. So that's how you see 4 represented. So we're going to write a 4 at the side. And teachers, if there are any teachers watching this, what I did with my students is I made a copy of this, and I had the students glue these down into their journals, and they had to write an explanation for how they were able to see 14/3 times 3. All right, now let's figure out, how do we see 14/3? Well, if we go ahead and count the boxes straight across, let me go ahead and erase this. We count our boxes straight across, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and one that is not shaded, but this is still in a box that has been partitioned into thirds. So this represents 14/3 shaded. So I have 14 shaded, partitioned into parts of 3. Okay, so 14/3 times 4. So you could say, I see in terms of your explanation, I see 4 rows with 14/3 shaded in each. Another student said, I see 14/3 4 times. It's another way that you can see that. All right, or you can explain that. Next one. How do you see 56/3? Well, let's take a look at that. I can count all of these partitions and know that this is 56 thirds. Let's go ahead and do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. So you see how long that takes? This is the longer method. Is it going to give you the right answer? Yes, but this does stand a chance that you could make an error, like you miss a spot or just miscounting, any form of miscounting. Okay. So I wouldn't recommend this strategy, but can you get the right answer? Absolutely. Absolutely. All right. And you know that it's 56. Again, this is a unit that is partitioned into thirds. So you know our denominator is going to be 3. Okay, so let's take a look at our next one. We have 18 thirds, and we have to figure out where do we see 18 thirds. So this is what we're going to do. I'm going to map out and show you how I see 18 wholes. So what I'm doing right now is I'm just drawing or outlining the whole unit that shows 18 thirds, excuse me, that shows 3 threes shaded. That represents one whole shaded. Now, you don't have to do this, but I'm showing it to you in 2 different colors so that you can see it better. I like color, so that helps me be able to understand it better. As you can see, it's pink, then purple. Oop, undo that one. Okay, because that's pink. Yep. Let me go in order. Pink, purple, pink, purple, pink, purple, pink, purple, pink. All right, now what I'm going to do is I'm going to go through and I'm going to label all of my units, whole units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you're probably saying, hey, that's only 16, but the number here it says 18. Well, how do we get 18? Well, you learned in previous lessons that what you can do is you can complete a unit by just moving over some sections. So for this one, we're going to move this section over and we're going to shade it in. And guess what? That gives us a whole unit right here. And we're going to label that 17. So that goes right there, just so you can see it better, right? And this is shaded now. So that means this is gone. It is no longer there. Now what I'm going to do is move this one down here, move it down here, and we're going to shade that. And this one no longer exists because we're moving it. And now that gives us a box here, our whole unit here, and that gives us 18. Okay, and these 2 pieces right here would be 2/3. So 18 and 2/3. That will be the area for this whole rectangle. Next one, how do we see 4 and 2/3 times 4? Well, again, we have 4 rows right here. 1, 2, 3, 4, 4 rows. And how do we see 4 and 2/3? Well, this would be columns. We have 1, 2, let me change my color. 1, 2, 3, 4, and 2/3 right here. 1, 2, 2/3. So I could label up here as 4 and 2/3. Now, I wanted to take a moment and show you all how to solve it, because this would be an answer choice if you didn't have to find a solution. This would be, they might ask you, well, choose all of the options that show an expression for this image. And you need to know that this one, as well as all of the previous slides, are the answers for that you might see as an answer choice. And you need to choose all of them in order to receive credit. And that's if all of them are there. Okay, now let's break this apart, right? We have 4 and 2/3 times 4. Well, if I just take my whole portion right here, just take all of my whole, well, I know that this total amount, 4 times 4 equals 16. And let me write that out. 4 times 4 equals 16. But guess what? We're not done, because we still have 2/3 here, 2/3 here, 2/3 here, 2/3 here. So that would be 4 times 2/3. And we learned in our previous lessons that in order to find the area of that portion, we need to multiply straight across. So in order to make a whole number a fraction, we put a 1 underneath. We'll just go ahead and multiply straight across. 4 times 2 equals 8. And that would be, and then 1 times 3 equals 3. Now, the next step in this is making sure that you change that improper fraction into a mixed number. So what I taught the kids to do is make a house for 8, okay? And move 8 into the house, also known as our division house. And you ask yourself, let's go ahead and put that in there. So we're dropping our 8 into the house. So we ask ourselves, how many groups of 3 can we make in 8? And we know that is 2. And 2 times 3 equals 6. 8 minus 6 equals 2. And we take that 2 and bring it up here. And we make it a fraction, because that's not a whole number. That's like a remainder, a portion of it, a piece of it is left. So that would be 2 and 2/3. And now we add those two numbers together. Let's go ahead and change colors. So our first big rectangle is 16. Also, it could be considered a square because it's 4 times 4, it's equal. Times, excuse me, not times, but plus, because we're adding our two products. 16 plus, ooh, you don't want to write today. 16 plus 2 and 2/3. And that will give us 18 and 2/3. That's only if the question is asking you to find the area of the rectangle, all right? Okay. All right, well, I do thank you so much for watching. Hopefully this video helped. Again, this is what we did in class. So review this video so you know the different ways that you will see those expressions come up, so that you're not confused. All right. Thank you so much for watching. I'll see you in lesson 12.